Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design bandstop filter with open circuited stub. So this figure shows the transmission line network of a bandstop filter with open circuited stub where the shunt quarter wavelength open circuited stubs are separated by unit elements. So the meaning of the unit elements mean connecting lines, so that are quarter wavelength long at the mid stop band frequency. So this is the layout of a microstrip wideband microstrip bandstop filter. So this is the layout of a microstrip wideband bandstop filter. So now here in this design, a microstrip bandpass filter of this design based on the 3-pole Chebyshev low-pass prototype filter with a passband ripple 0.05 decibel. So now here in this design, bandstop filter with open circuit stub is designed. Consider the type of the material is Rogers RT or Duraide 6006 and its dielectric constant is 6.15 and height or thickness of the substrate is 1.27 mm and considering the operating frequency is 2.5 GHz. Now go to HFSS software. So now here the length of the substrate is 45 mm and width of the substrate is 30 mm. So first draw the substrate, select the box. So draw the box anywhere in the plane. So give the rename of this box substrate. So change the type of the material. So the type of the material is Rogers RT Duraide 6006 and its dielectric constant is 6.15. And now change the dimensions of the substrate. So the substrate length x size is 45 mm and y size is 30 mm and jet size thickness is 1.27 minus 1.27 mm and position and x position is half of the x size value before indicating negative sign minus 22.5 mm and y position is half of the y size value before representing negative sign and z position is 0 mm. So click OK button and this is substrate. So below the substrate we can design ground plane. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane, give the rename of this rectangular sheet, this is ground plane. So the length and width of the ground plane is same as that of the length and width of the substrate. Now the z position is minus 1.27 mm and this is ground plane and this is substrate. So on the top of the substrate we can design open circuited stub bandstop filter. First to draw the 50 ohm transmission line both the ends. So this 50 ohm transmission line length is 7 mm and width is 1.85 mm. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. So this is 50 ohm transmission line and x size is 7 mm, length is 7 mm and y size is width is 1.85 mm and position and x position value is 22.5 mm and y position is 6.5 mm and z position is 0 mm and this is 50 ohm transmission line this end, and similarly draw another 50 ohm transmission line of another end, and select this 50 ohm transmission line, copy paste. This X position is minus 22.5 and X size is plus 7 mm. So click OK button, and this is another end of the 50 ohm transmission line. Next, draw the main transmission line. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane, and this is main transmission line. And this main transmission line length is 31 and the total length is 45. Total length is 45, and this is 7 mm, 7 mm, 7 plus 7 14. So 45 minus 14, the remaining value is 31. So the length of the main transmission line is 31, that is X size minus 31, and width is 0.45. Width is 0.45 mm, and Y size is 0.45 mm. And position and X position value is 31.2, 51, 31 by 2, and Y position is 7.2, Z position is 0. And after that, design this line and this line and this one. First draw this middle one, and this middle one length is 14.85 and width is 2.3 mm. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane, and axis is the Z axis, and size is, that width is 2.3 minus 2.3, and length is 14.85, and the position and X position is half of the X size value, so 2.3 by 2, and Y position is 7.2. Next draw this end of the line. Select the rectangular sheet. Draw the rectangular sheet anywhere in the plane, and this width is 0.3 mm and length is 15.15 mm. So plus from here to here this 15.15 mm, and this width is 1.85. So this 15.15 plus and half of this width value, so 1.85 half, so that is 16.075 mm. Width is 0.3 mm and Y size is 16.075 mm, and the position and X position is 15.5 and Y position is 7.2 mm, Z position is 0. So click OK button. and select this rectangular sheet. Press Ctrl C, Ctrl V. And now select 50 ohm transmission line, both the ends, this main transmission line and this three open circuited stubs. These three are the open circuited stubs. Select all these ones, select unite button. So first select 50 ohm transmission line, both the ends, main transmission line. So three open circuited stubs. Click unite button. These all are the unique. Now assign perfect electric boundary of the open circuited band stop filter and ground plane. Select open circuited stub, band stop filter and ground plane. Right click on that portion. Go to assign boundary. Select perfect E boundary. Click OK button. So this is perfect electric boundary. And now rotate this structure. Next rotate this structure. Change the plane. And this is y axis and this is z axis. Select the plane, YZ plane. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. This is port 1. And Y size is width is 1.85 mm and Z size is minus 1.27 mm and position is 22.5 and X position is 22.5, Y position is 6.5, Z position is 0 mm. Click OK button. So next give the analysis setup. Go to the simulation. So now the operating frequency is 2.5 GHz. Maximum number of passes are 12. So this green color curve is the band stop response.